Hello everyone, welcome to the last session of the statistical analysis using Excel data management system. So we are fifth week of our data analysis workshop, where we have studied different interview questions and how you can deal with data related to ANOVA, which is analysis of variance. This is a very important question when it comes to interviews for data analysis job positions. Whatever industry you might prefer, there will be some task that you have to pick up in terms of the sort of data we are dealing with. So today we have our last class where we're going to learn how to manually, create and understand data visualization from ANOVA. To do it, we first suggest to look at the question that you have. So here we have been asked that how does the level of octane quality affect the engine horsepower? So this is basically talking about the quality of the octane. So you will have categories of octane, let's say octane 1, 2, 3 and so on, and you have given 10 samples here. Therefore, the level of differences in the horsepower that actually depends upon the quality of the 4 category sample data that we are provided. If we just go and see what kind of data we have to deal with, so this is our data here. You can see we have been given 4 categories of octane: octane 87, which is one, then octane 89, 91 and 93, and we have 10 entries for each. Now, how do we basically go about this? The interviewer wants to see a decision, and based on that decision, you have to provide with a logical visualization. So what we see that we first visualize and then we go for the identification. Now, the most important thing that student makes mistakes is that they just go for the data analysis tab and just saying the numbers. They might feel, okay, if this is statistically significant, we can go for the decision. But you need to learn how you can manually understand, or if you manually enter the formulas that we have to learn. Otherwise, in most of the data sets, let's say you have different types of data sets, so in that case you might fail to identify which ANOVA you have to apply there. So it's better you learn how to manually sense the data that you have. For example, this section here, this is the average of all them, so we'll write them in a bit here. But so we need the mean, we need their variances, standard deviations and so on. Also in this video we're going to learn that how we go for the sum of square calculation. Then we have the sum of square within a group calculation. So one is between group calculation, another is within group calculation. So you need to find mean squares as well. So what I suggest that you should read the basics of ANOVA theoretically. If you can understand the theories first, and then you can jump to the practical session that we are following in our page here. So for this data, let's say we want to start with separating all these categories. So what we're going to do, we're going to write here category, which we have 87, then we have 89, then we have 91, then we have 93. So we are processing the data here, right? So this is 1, and then we need the mean values. So how we calculate the mean values, we have our formula in Excel which is called equal average. You open the argument here, and if you select the first range of the category that we have, if you close the argument and if you hit enter, see we have the mean values. Just drag them. We have the mean values of the 91, 93, 89, 87 octane. Also we need the variances. So we calculate variances by writing ARS. This is also a very popular formula, and then you again select the whole range that you have here and you close them. So now that we have the variances and the mean, we can go and calculate the standard deviation as well. So standard deviation, for the standard deviation we use equal STGEV. We open our argument here, and then again, just like the mean and the variance, we again select our first category here. Just close the argument and hit enter. See, we have our standard deviations as well. Now, looking at these, you can also say that there are some other stuff that we want. For example, if you want to calculate, let's say, mean square and the subsequent formulas that we want, for that we're going to need something called the grand mean. So the total mean of all the values here. So we'll just write here grand mean and set this a bit. Then we just again write equal APE RAGE average. If you open the argument here, just select all the data that you have here. This is all this one. You close out the argument. If you hit enter, see, this is our grand mean. So we have our categories mean, variances, and standard deviation with grand means. I'll just remove this part now. Alright, we have two hypotheses. So as you know that in ANOVA, the decision making is always connected to a hypothesis. So if you see that that your data is showing results which are statistically significant, in that case you need to go for a decision. Now for the decision, we use something called hypothesis testing. We have two hypotheses given here, which is hypothesis A, alternative hypothesis, and the null hypothesis. So the null hypothesis say there exists no differences between the mean values. So what it's saying that there is no difference in the horsepower of given the quality of the octane that we have. And the alternative of that is just the opposite. What we as a researcher want to find out. Let's say we are saying that there exist differences between the mean values. That means there exists some difference between the groups or within the groups, whatever it is, the differences are actually there. So if we find our results statistically significant, we will reject the null hypothesis and we will say that there exist differences between mean values. Or if we don't find the results to be statistically significant, then we say that we do not reject the null hypothesis and there exist no differences between the mean values. Now this is really important. Again, I'm saying that the theoretical understanding of the ANOVA and the hypothesis test is important. How do you calculate the sum of square? So the sources of variations, understanding of that is important. So your population data and the sample data needs to be clearly defined. So when we say that we are calculating variances, this says that how much your data is spread. So that means larger the number of variance, larger your data is spread from the mean value. Then you have the standard deviation, which says that how much your data deviates from the mean value. So then we also have standard errors and so on. Now let's say we want to see the sources of variation. Now how do we really do it? Sources of variation gives you an idea that how your data is likely to be give us a statistically significant result. For example, if you have, let's say, between group sum of square, then you can get a mean square from between group, and same for the within group data. All right, in that case we then further move to calculating the F value. So again, these things might seem a bit off track if you do not have the theoretical understanding. Again, theories are important to understand the whole ANOVA analysis. So let's say now we want to find out the sources of variation. So to manually go for the F value calculation, we need the sources of variation. So one is we have let's say one sources of variation is the between group error. Then we have within group error, right? And let's say we also want to see the total of that. So here we have the sum of square, then degrees of freedom, and we also need something called the mean square. Mean square values. All right. So let's say we first want to calculate the between group error. We need the squared difference between the grand mean and the individual mean of a group for the between group error calculation. And then we sum all of them all together and then we multiply them with 10. So for the between group error, what we write is that let's say we want to multiply by 10 because we have 10 data points, right? 1, 2, 3, 4, like this. We have total 10 samples here. So we'll first type equal, we'll write 10 multiply. If you open the argument here, and then we want the first grand mean, all right? Then we minus it from the actual mean of first category. If you close the first bracket and we square them, all right? Then we again hit plus, same. If we open the first bracket, we select the grand mean, we minus it from the actual categorical mean that we have in the second category, close the first bracket, and again just put square, then again plus the first bracket, the grand mean minus the actual mean of the third category, close the bracket, and then again just put square. Then once again for the last category, we'll plus, we'll open our first bracket, we'll select the grand mean tab, we subtract it from the fourth category here, we close the first bracket, we put a square, and we completely close our argument here. So what this made that for between group understanding, to understand the error in the between groups, we have total 10 samples, and we want to see them in their summed differences from the grand mean to the actual mean of the category. Now you can also use SUM SQRT, sum square root formula, but in that case you will have a smaller number, but the decision making might not get affected, but the number will be a bit incorrect. All right, so if you just hit enter here, see we have our between group error in just in second. Now we also need our within group error correction. Here we use a formula called equal sum product. Why you are using sum product is that we do not want to compare it with the grand mean. We don't want to compare the squared sum with the grand mean. What we want to see is that the all data points that we have, all of this, and then we'll subtract from the mean value now. All right, so we'll just select all the data points we have here, so sum of all this, and then minus, we'll select the mean value. All right, we'll close, and again just put a square because we want the square differences. All right, then again put plus in the first bracket, again select the second category of octane from here, then subtract it from the second category mean, then just close the first bracket, and again put a square, again hit plus, same to the second category. For the 91 octane category, select all of them for summation, and then subtract it from the third main category that we have at 91. Then again just close the first bracket and put a square, again hit plus in the first bracket, select all of them, the fourth category now, and then subtract it from the 93 category here. All right, and if you just close the first bracket and again put a square and close the argument properly, and if you hit enter, we found a typo in your formula, you correct it. Yes, there are some issues in the formula. We have to put a bracket here, you missed a bracket here, that's why it was showing an error. If you now close the argument properly, and if you hit enter, see we have all our within group error appeared. Right, now we have the total here. If you just type equal, select this plus this, enter, we have the total. Now the degrees of freedom for the between group error, here we are talking about between group, that means the degrees of freedom should reflect the total group minus 1, that is 3. We have total 4 groups here, 1 2 3 and 4, minus 1 is 3. All right, then degrees of freedom for the within group error, that means when you're talking about within group, we have 4 groups and total 40 entry into that, and if you subtract 4 from 40, we'll have 36. So degrees of freedom for the within group error is 36. Now we can move to calculate the mean square. To do it, we we divide the sum of square by the degrees of freedom. So to calculate the mean square, we need sum of square, the source of variation first for the between group and then for the within group. So what we do is that we put a equal sign, and then we select the sum of square value divided by the degrees of freedom. You hit enter, you have the first mean square, and for the second one we again put equal, and then select the sum of square value for the within group error, and then degrees of then we divide it by the degrees of freedom that we have for within group error calculation. Right, if you hit enter, see we have now almost all the manual numbers that we needed. We have the mean, we have the variances, we have standard deviation, we have our grand mean. Now also we have calculated our sources of variations, where we have our sum of square, degrees of freedom, and mean square calculated. Now we want to see the f value. If you know that the f value is calculated from mean square, so if I just write here that the calculated value, the first one is equal to, we put equal, then we use the mean square of between group error, we divide it by the mean square of the within group error. right? So the ratio of the mean square from between group and within group will give you the F calculated value. So we have 146. So this is basically mass divided by mass within, right? So as you can see that we have the values that we wanted. Now we have to go for the decision. For that, it's better that if we visualize it somehow and then we go for the decision making. So if you see, we have F calculated value here. So for the F critical value, we see that the F must find the 0.05, sorry, will be 0.05. That means with 95% confidence, we want to say that the degrees of freedom for the between group, and we also see that the degrees of freedom for within group error. And if you go and see the value in the F table, from the table, if you see, the value is 2.866. all right, and if you see a bit carefully, that these two values are actually giving us our decision. That means if the F calculated value is much higher than the F critical value, we reject the null hypothesis. Now this is visible that we have a statistically significant result for our data from the F value. Now let's say we have to visually see the trend. Now the interviewer did ask to find a trend in the data. Now how you can go for the trend analysis? If before that, if you just write that if F calculated value is much larger than the critical value, we reject the null hypothesis, all right, which is the H0. That means we want to say that there exist differences between the mean values, which is statistically significant from our data. It's proven, all right. So now to visualize, we just select the category and the mean values and go to insert. From there, just insert we want to insert a line. Let's say this one. If you enter this, see our data now completely gives us a trend between the categories of octane, which is 87, 89, 91 and 93, and the trend in our data that as the quality of the octane is increasing, the horsepower is likely to change. So if you just now click on this plus tab, and if you add access titles that we want, we also want error bars. If you go there on the error bars, we want to see we want different standard deviation. So for that, this is for the vertical error bars, right? Here we will go to custom and we'll specify the value for the error bars. We have our standard deviations here, all right? So for the up, or the how much above we want to see our error bars to lie, is this one for the positive values, and also for the negative values we want to constrain the bars with the same values, right? And then if you just hit OK, you'll see our error bars have arrived. If you click on the horizontal error bars, we actually don't want, so we'll put this value of 0.0 here. That way it might move away. So now we have the error bars plotted very precisely. If you see that the 89 octane or 87 octane differs a lot from 89 octane and so on, 190 and maybe 91, right? So if you put a title here, you can give a title that I've already plotted here, trend in quality of octane and horsepower. Then you put H3 from here, and then the octane qualities from here. So being the access titles and the bars is that you click on this plus here and you see that you have access titles and error bars. Inside error bars, you have to go for more options, and from here just remove the horizontal error bars. What you can do is that just click on horizontal, just click on fixed values and put 0.0 here. All right, it will be removed. The horizontal error bars, we don't care about them. It's just showing you your data is one standard deviation away from the other. All right, and if you want the vertical ones to be aligned, then you just click on the error bars here, vertical ones, and then go to custom, specify value, and then just select the values of your standard deviations that we have. So this is the constraint for our how much above we want the data to go, the error values, and how much below. This two, all these data. You just hit OK. See, your error bars have actually changed. See, this means the different quality of the sampled data has different precision, and they differs from one another. It is quite visible from here. You can also change a lot of stuff from this chart. You can design it the way you might want, and I hope all these type of classes has helped you all. And I also think that in the January and March classes, many of the current students will be attending. So you can change, see, you can change the different things like this. So I hope you enjoyed the last 5 weeks classes where we have completed the statistical part using Excel or using the practical data management system in analysis of variance, ANOVA. And we are starting a different topic from January, where you will be meeting with other industry experts who have dealt with this type of data analysis workshops or interviews since last 7-8 years. So they are the nodal officers who actually brings all the examples and how to go about them. So again, thank you all of you to join, and I hope you will be expecting something better from January to March. So this is how we plot our data in analysis of variance, trend analysis, and there we have to do a hypothesis testing to just visualize the decision making. So in this example, our decision is that we reject the null hypothesis here, the H naught, and we say there exist differences between the mean values. So I hope you understood. Thank you so much. I'll see you in the next class. Jai Hind.